Interfaces differ from regular inheritance in their areas of use. However, in terms of programming, there are hardly any differences between interfaces and regular inheritance. Interfaces can be seen as superclasses that cannot be instantiated, do not contain implementations, and have only public components. You can simulate multiple inheritances using interfaces. In ABAP objects, interfaces primarily serve to define uniform interface protocols for services. Various classes can implement these services in different ways, but you need to keep the same semantics. Therefore, interfaces contain no implementations.
Compared to regular inheritance, the distribution of roles in interfaces is sometimes different. The user generally defines the interfaces. In these interfaces, the user describes both technically and semantically the services that the user wants the providers to offer. Each class can now decide for itself whether it serves the interface, that is, whether it actually offers the services defined in the interface. Therefore, this case is similar to a specialization relationship with a subclass. As with regular inheritance, access to these services defined in the interface is then usually generic, that is, access to the services uses a reference that is typed on the interface. As an inheritance, polymorphism can also be implemented in interfaces. In Unified Modeling Language, or UML, you represent the interfaces in the same way as you represent classes. However, in addition to the interface's name, you use the notation interface. You represent the use of an interface by a dotted line with a two-sided arrow from the user to the interface. The keyword uses is optional. In ABAP objects, you can define the same components in an interface as you can in classes. However, interfaces do not know the visibility levels of their components. That is, all the components of an interface are public. Classes implement interfaces in the following ways. Interface name. The interface name is listed in the definition part of the class with the interfaces statement. This occurs in the public section, that is, interfaces can only be implemented publicly. Interface methods. The interface methods are implemented in the implementation part of the class. Interface components. The components defined in the interface are addressed in the implementation part of the class. Interface components are distinguished from the other components in the implementing class by prefixing the interface name followed by a tilde, which is the interface resolution operator. Interface underscore name tilde component underscore name. To simplify access to interface components, you can use alias names. These alias names can appear in the definition part of a class or in the interface definition. The use of alias names is subject to the visibility restriction of the defining class. An alias for an interface method is defined as follows. Alias is A_1 for LIF_1 tilde method _1. The interface method LIF_1 tilde method _1 can be addressed with a shorter form REF static A_1. You can access interface components only by using an object reference whose class implements the interface. You use the interface resolution operator tilde to access the interface components in the implementation part of the class. Alternatively, you can use the alias names defined in the implementing class for the interface components, even if shared components of the implementing classes are subsequently transferred to the interface. Access to these components does not need to be adapted.
An interface reference can only refer to instances of classes that have implemented the interface because interfaces themselves cannot be instantiated. As in regular inheritance, you must use upcast to copy a reference to the interface reference variable to perform polymorphism with interfaces. If the class has implemented the interface, it is certain that all the components that can be accessed syntactically after the cast assignment are available in the instance. A user can address the instance of the implementing class using the interface. The prefixing of the interface name and the interface resolution operator is omitted. However, the user is restricted to using the components from the interface. In the example, the display_partner and check_availability methods of the LIF_partner interface can be accessed only after assigning the reference variable go_partner. It is not possible to access the specific components of the instance from the LCL_rental, that is, get_name in the above example class using the go_partner reference variable. Therefore, the view narrowed or at least remains unchanged. That is why you describe this type of assignment of reference variables as upcast. There is a switch from a view of several components to a view of only a few components. The target reference can, of course, accept more dynamic types after the assignment than it could before. Therefore, the term widening cast is also suitable.
A typical area of use for upcast assignments is preparation for generic access. A user who is not interested in the finer points of the instances of the class that implement the interface but who simply wants to address the components defined in the interface could use an interface reference for this access. In the example shown, a travel agency, LCL Travel Agency, needs to manage the various kinds of business partners in one list. The developer must therefore assign the row type of the internal table as a reference to the interface LIF partner. The travel agency only wants to request the services in order to display their attributes and check their availability. The relevant display partner and check availability methods are defined in the LIF_partner interface and implemented in all business partner classes. The objects of different classes such as LCL Hotel, LCL Rental, and LCL Carrier in the example can be kept in an internal table, typed with interface references LIF partner in the example. The components defined in the interface can then be accessed uniformly. For this example, the add partner method is needed. This method copies the references to all kinds of business partners in the internal table. The import parameter of this method is already typed as the reference to the interface.
Polymorphism can also be performed for interfaces. You can use interface references to call methods and execute different implementations depending on the object of the reference. The dynamic type of the reference variable is used to search for the implementation of a method. In the above example, LO_partner static display_partner uses the class of the instance to which LO_partner actually refers in order to search for the implementation of display_partner. The implementation that is executed when display_partner is called now depends on the object to which the interface reference LO_partner currently refers. When objects from different classes react differently to the same method calls, it is known as polymorphism. The option of performing polymorphism is one of the main strengths of interfaces. A client can handle different classes uniformly regardless of their implementation. The runtime system searches for the right implementation of a method on behalf of the client. Polymorphism can be used to write programs that are highly generic, that is, they do not need to be changed significantly if use cases are added. In the example, it becomes easy to add a class for boat rentals. For example, The relevant class with the name LCL Shipping will simply have to implement the LIF partner interface and the display partner method defined there. Business partner management can then easily include ship-owning companies and request them to display their attributes.
To assign an interface reference to a class reference where the class has implemented the interface, you must use the downcast assignment operator move $2 or its short form $equal to. Otherwise, the system would return a message stating that it is not certain that all components that can be accessed syntactically after the cast assignment are actually available in the instance. As a rule, the implementing class contains more components than the interface. Interface reference variables can contain references to instances of the implementing class at runtime. After assigning this type of reference back to a reference to the implementing class, clients are no longer limited to interface components. In this example, you need to know whether it is useful to define a further service for room reservation in the interface LIF_partner. In this case, the classes LCL_carrier and LCL_rental need to implement the appropriate method because they have integrated with the interface LIF_partner. However, keeping the same semantics is not conceivable for airlines or car rental companies when we implement the room reservation service. However, because there are several other business partner types for which this implementation is useful, for example, motels and hotels, the method needs to be defined centrally and not individually for motels and hotels. If we also need to extend the model with other accommodation provider types, for example, guest houses, then the interface hierarchy needs to be retained.
The including interface is a specialization of the included interface. The including interface is known as a compound interface. An included interface represents a component of another interface and is therefore known as a component interface, represents an extension of the included interface. An interface that does not contain other interfaces in itself is known as an elementary interface. The UML notation corresponds to the implementation of an elementary interface by a class.
As with regular inheritance, the implementing class only needs to list the compound interface in order to integrate all components. Nevertheless, the components of the component interfaces keep their original names. Component interface name tilde component name. They are therefore not prefixed by the name of the compound interface. All implementations of methods from all higher-level interfaces must take place in the first implementing class. Alias names are suitable for short-form syntax when accessing components from different interfaces. If the implementing class contains aliases, it provides a central view of all components. You need to address the components from a compound interface and do cast assignments the same way.
Interfaces enable different classes to be handled uniformly, provided those classes have implemented the interfaces. As with inheritance, you can also perform polymorphism using interface reference variables. As is the case with regular inheritance, the definition of an interface means the abstraction of the implementing classes to a specific aspect. Multiple inheritances can be simulated using interfaces. If several interfaces are included, all components are available to each of the interfaces and you must implement all methods.